Imagine you live on an unstable planet in the far reaches of the galaxy. Once safe for millions of years, your home is now plagued with scorching heat waves and violent storms. Your entire species is under imminent threat of extinction. What choice do you have but to flee and find a more habitable planet? Back on Earth, this horror story might seem distant in humanity's future, but for the hundreds of tiny marine species living on our coastline, it is Armageddon. For them, traversing miles of rocky shore to escape climate change is as treacherous and unknown as interplanetary travel for humans. In my eyes, these creatures are like ancestral fortune tellers, because whatever tragedies they endure will likely follow in the wider ecosystem over time. By understanding how they respond to climate change, which my thesis aims to do, the more we can do to protect them and our planet's environmental future. However, visual surveys used to locate these species are difficult to scale up and often miss hard-to-see species. But what if there was a better way? What if everyone in this room could identify hundreds of species without even seeing them? Well, through the incredible power of DNA, we can. Every living thing on this planet has DNA, and every second we shed that DNA into our environments, which is known as environmental DNA or eDNA. Like a high-tech barcode reader, I can scan eDNA from seawater to seek out marine life and ultimately understand the health of our rocky shores. So for my thesis, I set out on an epic adventure, like Mr. Spock armed with his trusty tricorder. My mission? To determine whether eDNA can accurately track our marine fortune-telling species. And not only did I detect our fortune tellers, I found so many more that I wasn't even looking for. I uncovered 270 different species in just one single water sample, and over 1,800 species across the whole project. I found that eDNA was very sensitive to changes in marine communities. This included changes over large distances, like between Scotland and Cornwall, or between Mars and Neptune if you ask the sea snails, but also within small areas, like between rock pools and open water at the same location. So even in ever-changing environments like the intertidal zone, eDNA showed great potential to track species across their perilous journey through their mini-solar system. We're still far from real-time environmental scanners like in Star Trek, but could eDNA be the final frontier for our environmental crisis? Our origins began in the ocean, and if we do well to understand its future, we might just be able to save our own.